Hello students, welcome once again to Chem. In this video, we want to talk about the introduction to nuclear chemistry. But before we talk about the introduction to nuclear chemistry, we have something drawn over here, which we are all aware of. That is the basic structure of the atom. From this structure, we can see that the atom is made up of a central part, which we call nucleus. This central part contains two elementary particles. One is called the proton, which is positively charged, and I'm representing with the plus sign. And the other one is the neutron, which has no charge. So I'm representing with a 0, meaning it has no charge. These two particles are found in the nucleus of an atom. Outside the nucleus of the atom, we have shells or energy levels, where we have negatively charged particles called electrons. Now, this is not actually how the atom looks like, but for the sake of our discussion, to make everything easier for us to understand, let's assume this as the structure of the atom. When we talk about nuclear chemistry, we'll be looking at not the outermost part of the atom, no, not the shell containing the electron, no. We are not going to talk about this part. So all these parts, we are not going to consider them. We'll be considering the nucleus containing the protons and the neutrons. Hence the name nuclear from the word nucleus. We'll be looking at the changes that goes on in the nucleus. From chemical bonding, we realize that atoms lose, gain, and share electrons to achieve stability. The nucleus also has its own problems with regards to stability. How does the nucleus address these issues of instability? That is what nuclear chemistry is concerned about. So nuclear chemistry is the branch of chemistry that talks about the changes that the nucleus of an atom can undergo. And all these changes occur because the nucleus would like to be stable. Before we delve into nuclear chemistry, there are some terminologies that we need to really understand. These are the terminologies we need to become aware of entering into nuclear chemistry. The first one is called atomic number. When we say atomic number, it refers to the number of protons in the nucleus of an atom. So the number of protons in the nucleus of an atom is what we call the atomic number. This is a unique number because no two elements have the same atomic number. Atomic number 1 belongs to only one element, and that element is hydrogen, because hydrogen has only one proton. Atomic number 13 belongs only to aluminium, because aluminium is the only element on the periodic table that has 13 protons. So the number of protons in the nucleus of an atom is what we call the atomic number. The next terminology we need to become aware of is nucleon. Nucleon. The name looks like nucleus, but at the end it changes to ON. That is basically because nucleon refers to the protons and the neutrons in the atom. So this one refers to the protons and the neutrons in an atom. That is nucleon. Then we have one beneath it called the nucleon number. Now the nucleon number is the sum of the number of protons and the number of neutrons in the nucleus of an atom. Don't let us confuse nucleon number with nucleon. Nucleon refers to the protons and the neutrons in the atom. Then the nucleon number refers to the sum. So number of protons, which is proton number, plus number of neutrons, which is the neutron number. When we add them together, those two numbers together, we get what we call nucleon number. This nucleon number also has another name. We can also call it the mass number. Mass number. Next in line is isotopes. Isotopes are atoms of the same element with the same number of protons but different mass numbers. And the mass numbers are different because the number of neutrons change. So let's take an example. We have hydrogen existing in 3 different forms. All of them have 1 proton because proton number 1 belongs only to hydrogen. It is the only element with only 1 proton. So atoms of the same element, hydrogen, with the same atomic number or number of protons, which is equal to 1. But their mass numbers differ. So over here, we have hydrogen 1, hydrogen 2, hydrogen 3. Their mass numbers, which are written as the superscript, exhibit changes because their number of neutrons are changing. Over here in hydrogen 1, we have 0 neutrons. In hydrogen 2, we have 1 neutron. In hydrogen 3, we have 2 neutrons. Now, these isotopes of hydrogen have unique names too. This one is called the protium. Hydrogen 2 is called deuterium. Then hydrogen 3 is called the tritium. So isotopes, atoms of the same element, same atomic number, but different mass numbers, caused by the changes in the number of neutrons. We do have isotopes of carbon, being carbon 12, 13, and 14. Isotopes of oxygen, oxygen 16, 17, 18. We have isotopes of many elements in existence. That is isotopes. And in representing isotopes, we write the symbol of that element. And to the left side, as a superscript, we write our nucleon number or our mass number. And as a subscript, we write our atomic number or the number of protons. The last thing in line is nuclide. Nuclide. When we say a nuclide refers to any atom whose number of protons and number of neutrons are known. So if I have carbon like this, if I have carbon like this, from this, we know that this carbon atom has 6 protons, but we have no idea the number of neutrons in this carbon atom. So we can't say this is a nuclide. But the moment I write this, I know the atomic number, and when I subtract the atomic number from the mass number, I'm going to get my number of neutrons. So since I know my atomic number and my neutron number, I can say this one is a nuclide. We can also define nuclides as any atom whose atomic number and mass number are known. So it's either we know the atomic number and the mass number, or we know the atomic number and the number of neutrons. Definitely, if you know the atomic number and number of neutrons, you can just add them up to get the mass number. If you know the mass number and atomic number, you can just subtract and get the number of neutrons. So both definitions work. So any atom whose number of protons and number of neutrons are known, or whose number of protons and mass number are known, is what we refer to as nuclide. Now, since we know these things, in our next video, we'll be talking about stability of isotopes. Thank you.